Hey everyone, and welcome to this explainer. So today we are taking a really structured step-by-step look at a topic that is absolutely dominating the tech world right now, AI agents. You hear these buzzwords literally everywhere, right? But today we're cutting through all that noise to uncover the actual mechanics of how these systems operate, how they learn, and how they fundamentally differ from the tools you were using just a year ago. It's fascinating stuff, so let's dive right in. Now I gotta ask you a question to kick things off. Are you really using AI agents right now or just basic chatbots? Honestly, it's a vital question. I mean, most of us interact with AI every single day, right? We ask it to write emails, summarize long documents, or just answer random questions. But there is this massive misconception out there that simply typing a prompt into a text box means you're using an AI agent. And, well, it doesn't. To really understand why, we need to look at how artificial intelligence has evolved over the last couple of years. Think of it like an evolutionary map. We started at level 1 back in late 2022. This was the classic chatbot phase, driven mostly by natural language processing. It understands what you type, and it generates a response. It's basically highly advanced autocomplete. Then we leveled up to level 2, reasoning. This is where models started using something called chain of thought to actually think through complex problems step by step before just spitting out an answer. But Level 3 is where the real magic happens. This is the agentic level, which represents virtual human autonomy. At this level, the AI isn't just answering questions anymore, it's making self-determined decisions to actually achieve a goal. To really wrap our heads around this leap, let's look at a pretty fantastic real-world analogy. Okay, imagine you're walking into a restaurant. You are served by a waiter named Mohan. Now, Mohan represents traditional level 1 AI. He's perfectly accurate. You order a pizza, he writes it down, and boom, he brings you exactly what you asked for. But he is entirely reactive. On the flip side, consider another waiter, Madhav. Madhav represents agentic AI. He remembers that you ordered the green kebab last week and casually asks if you want it again. He notices it's freezing cold outside and proactively suggests a nice bowl of hot tomato soup. See the difference? He anticipates your needs and acts independently. He's an independent thinker. So let's translate our two waiters into software. A standard intent-based bot maps a phrase, like "what are your store hours," to a hard-coded answer. It's super rigid. Conversely, an agent-based bot is basically Madhav in code form. It actually learns your Friday pizza habits. When you log in, it proactively asks if you want your usual order. But wait, it gets better. It can autonomously check the weather, realize there's a huge snowstorm coming, and proactively warn you that your delivery might be delayed. And here's the kicker. Nobody hard-coded that specific interaction. The agent just figured it out on its own. From an architectural standpoint, an AI agent essentially operates as a UI wrapper. Now, don't let the term UI fool you into thinking we're just talking about graphics and pretty buttons. A UI wrapper is an interface layer. It sits right between you and the incredibly complex back-end operations of a large language model. The agent simplifies your interaction. It takes your simple, high-level goal and translates it into, a dozen complex queries on the back end, so you don't have to do the heavy lifting. To make this perfectly clear, think about a car's interface. When you're driving down the highway, you don't manually inject fuel into the cylinders, mix it with the exact right amount of air, and time the spark plugs to create combustion, right? Of course not. You just turn the steering wheel and press the pedal. The steering wheel is your UI wrapper. An AI agent acts exactly like that steering wheel for a large language model. It handles all the complex engine operations, like iterating prompts, searching databases, parsing raw data, while you just focus on steering toward whatever your goal is. And this brings us to a really helpful way to look at this, the brain versus body framework. A huge misconception out there is that the large language model itself, like a GPT-4 or a Claude, is the agent. Actually, it's not. The LLM is merely the brain. It has all the intelligence, sure, but it is completely isolated. The agent is the body. The agent gives that brain hands to search the web, eyes to read your internal database, and a mouth to send out an email. Without the agent, the LLM is literally just a brain in a jar. All right, so that's the high-level concept. Now let's move into our next section, the engine room, architecture and learning mechanics, and see exactly how these things work. The real secret sauce here lies in reinforcement learning, which is built on 5 core pillars: environment, agent, input observation, action, and reward or penalty. Let me share a quick story from the source material that illustrates this perfectly. Imagine a young kid learning to ride a bike. The road is the environment. The rider is the agent. The dad warns, "Hey, watch out for dogs." The kid takes in this input observation, but chooses the action of ignoring it and speeding up when a dog suddenly appears. The result? A painful crash. That physical pain is a massive penalty or a negative reward. Because of that penalty, the next time that rider sees a dog, they automatically slow down. The agent learned autonomously from its environment through rewards and penalties, not just from being given a list of rules. Now, alongside reinforcement learning, agents utilize that chain of thought processing we mentioned earlier. Traditional bots basically gave you the very first answer that popped into their heads, the initial output. An agentic system, however, generates an answer and then moves to step 2, internal verification. It essentially pauses and asks itself, wait, is this actually correct? If it's not, it moves to step 3, expanded research, to gather more data. Only after iterating through this whole cycle does it present step 4, the final refined answer. It's acting like a meticulous researcher, continuously checking and improving its own work before ever showing it to you. And this is exactly how the agent's body operates using tools out in the real world. Say a user asks to place an order. The agent doesn't just pass that text directly to the LLM. It accesses a weather API, sees a storm rolling in, and generates a warning about delivery delays. It dips into the internal database, checks your past orders, and suggests your usual Friday reorder. It uses web search to research fresh data and provide updated context. The agent is orchestrating all of these tools completely autonomously, without a human programmer sitting there hard-coding every single step of the process. But wait a second. If it's so autonomous, isn't it going to go rogue? Well, not quite. This is where the concept of autonomy with a leash comes in. When developers build AI agents, they grant them freedom, for sure, but only within a very strictly designated radius. Think of it like walking a dog on a 2-meter leash. The dog can sniff wherever it wants within that radius, but it absolutely cannot run into traffic. An AI agent in our pizza shop example can independently suggest extra cheese or a hot chocolate, but it is strictly tethered so it cannot suddenly decide to give away free pizza to everyone on the internet. It has bounded autonomy. Let's tie all these concepts together with a really comprehensive definition straight from AWS. They define it like this. An AI agent is a software program that interacts with its environment, collects data, and performs self-determined tasks to meet predetermined human-set goals. Every single word there is deliberate. It interacts by using tools. It performs self-determined tasks through autonomy and chain of thought. But crucially, and this is the big one, it meets human-set goals. That goal is the leash. As we wrap up this explainer, I really want to leave you with a bit of a provocative question to chew on. If an AI agent is truly autonomous, if it's out there independently checking the weather, learning your habits, and making self-determined choices to achieve a goal, who is ultimately responsible for its decisions? As we start seeing agents manage entire enterprise workflows and super complex systems, understanding this architecture isn't just some fascinating technical detail anymore. It's something we all really need to think about. Keep learning, keep questioning, and I will see you in the next explainer.